Alright guys, so in this video we're going to be looking at a problem that deals with a spring. We're going to be looking at the force being exerted by the spring and also how it connects to energy and work. Alright, so here we go. We got a woman weighing 600 newtons stepping on a bathroom scale containing a heavy spring. The spring compresses by 1 centimeter under her weight. Find the spring constant of the spring and the total work done on it during the compression. All right, so if we look at just the woman here, and we look at the forces on her, she's got the force of gravity, which is down, and that's equal to 600 newtons, just like it says up here. That's her weight, the force of gravity. And then, of course, there's also the normal force of the scale, the bathroom scale, which is pushing up on her. All right. Now, we know that because she's standing on the scale that she's in equilibrium. So the normal force is equal to the force of gravity there. You could write out an equation for that, but we know that those two forces must be equal because it's not accelerated. Now, at this point, we know that the normal force of the scale on her, that's the force that the spring is exerting. And we know that the spring is compressing by 1 centimeter. Now, we learned that the force of the spring on an object is equal to negative kx. All right, now the force of the spring is 600 newtons upwards. We're going to try to solve for k here. The x is how far the spring's been compressed, which is 1 centimeter, but it actually has been compressed downward. So I'm going to put a negative 1 centimeter here. But you'll notice that I converted it to meters first. And then we'll notice that the two negatives are going to multiply and become positive. I'll divide that 0.01 and I'll get 60,000 Newton meters because that's the units for the spring constant. So there we go. We've solved for the spring constant. Now we're going to move over to the work done on the spring. Now, it's very, very tempting to go work equals force times distance, right? Because we know that the force is being exerted downward on the spring as it compresses. We unfortunately cannot do this. The reason being is because the force is not constant, right? That force, that 600 newtons, is only being exerted when it's compressed 0.01 meters, when it's that 1 centimeter of compression. All the rest of the time, if it hasn't compressed as far, the force is less. And so in order to find the work done here, because the force is not constant, we actually are going to need to look at energy. All right? Now, there's a couple of different ways that we can do that, but probably the easiest way is just to find out how much energy is stored in the spring. And so we're going to say the elastic potential energy is equal to 1/2 kx squared. And so we can do that 1/2. We can put the k in there, which is that 60,000. And then we'll multiply by the x squared, which is that 0.01 squared. And from there, we should be able to calculate the energy stored. Now when I do that, I get that the elastic potential energy is going to be equal to 3 joules. And so since there's 3 joules of energy stored inside the spring, that's how much work has been done on it. There you go. That's the end of that first question.